Every time my mom is driving me somewhere, I don't know if I'm gonna make it there. I was sitting in the back seat and I was like, oh my, I think I might die and I just go to Canada today. Exactly. Not even a cool car. I'm calling it a mom car.
Okay, so all this is in terms of like how chemistry is done. This is vastly important. So what you do is you start, there's two ideas that you have to start with. One is very subtle. One is the idea of what molar mass is, okay? So if I say, hey, what's the molar mass of carbon, what are you going to say?
12.01.
Well, hydrogen is 1, magnesium is 24.3, okay? The greater scheme of that was that they had the molar mass determined first. This is what actually, how they arranged the initial periodic table was based upon chemical reactivity and molar mass. And that was kind of the beauty of what Mendeleev did, is that Mendeleev actually left gaps in the periodic table saying, hey, I think there's going to be some things that we can figure out and we'll eventually fill in. So they understood the concept of molar mass. So the next kind of progression in the story was they said, okay, well, we know atoms are really small. This is in the 1800s, so this wasn't like, oh, we know that there's electrons, protons, and neutrons. Okay, none of that existed. All they knew is that here's the properties that they have: lithium, sodium, potassium. Oh, they're all silver soft metals. Oh, okay, cool, right? They react violently with water. All right, cool, we got those. You got the rare earth metals, magnesium, calcium. You got the main body. Oh, you got iron, silver. And then you got their gases of chlorine, hydrogen, oxygen, all that good stuff. So later on, they said, okay, what are we going to do with this number? Because it isn't realistic that I want to have Kevin go into the lab and go, hey, Kevin, I need you to measure out 5 oxygen atoms and put it on a scale, okay? It's just not going to happen. You're going to be dealing with large quantities of these. And this was literally the argument. They said, okay, we know the relative atomic mass of carbon is 12. Cool. So they came up with this concept of the mole, and this was the debate, was that what units are we going to measure this in? And they said, we got grams, we got kilograms, we got grams, we got pounds, we got ounces, we can do like the metric system, we can do the English system. What are we going to do? So this is about the time that the metric system had become all of the rage, okay? And they said, oh, hey, the metric system is cool. Let's use grams. So literally, what they did is they took like carbon, for example, which technically has a relative atomic mass of 12 AMUs, which stands for atomic mass units. So if you see this on the test, that's what it's talking about. So they literally said, okay, we're going to mark through that, and we're going to put 12 grams per mole. So if you have a mole of carbon, that's going to have a mass of 12 grams. In physics, they actually work off of kilomoles. So it sounds weird. It's like, what do you got, a kilomole? Sounds like what do you do? I'm a professional mole hunter. What do you do? I kill them all. So in physics, instead of grams, because they work off the MKS system, they would say 1 mole is a kilomole, which is 12.0 kilograms per mole, okay? If you're the English, we could say, oh, we're going to have the English mole. Okay, cool. Yours would be 12 ounces per mole or 12 pounds per mole. It's completely arbitrary, okay? But everybody just says, hey, we're in the chemistry department, we're going to call this grams. So the next task became even more difficult. That was the easy part. The more difficult part became Avogadro's number. And they said, okay, well, how many atoms is that going to take? You know, what do we got? How can we begin to measure this? So, again, why is Avogadro's number 6.02 times 10 to the 23rd? Kevin?
Because that's how many atoms make up 1 mole of every element.
you're 90% there. But why isn't that specific number? Why isn't it 5 or 10
It makes,
or 40?
it makes the like AMUs and the grams would be the same kind of like the number of AMUs for each atom when using that many of that particle makes that number of grams.
That was a convoluted way to say it, but you're
Yeah.
right. Okay. Yeah. So here's the basic idea. Is that if you take a pan balance, this was the idea. And let's say you want 12 grams of carbon. So here's this old style pan balance. So you're gonna put a 12-gram mass over here. Okay? You're gonna put a 12-gram mass over there. And then over here, you're gonna start to stack carbon atoms. Okay? Boom, there's 1, there's 2, 3. Okay? And you're just gonna start stacking carbon atoms. And you're gonna stop when these two are balanced out. Okay? That's when you know you have 1 mole. And that's going to take you 6.02 times 10 to the 23rd atoms to get to that point. Okay? Now, if you use magnesium is 24.3. Why is it going to, so if you take the same number of particles, 6.02 times 10 to the 23rd, why does magnesium have more mass than the carbon does? Gap Sean.
It's a different molar mass.
What did
You're going to jail for so many
Why
different
would you say
reasons right now.
Oh, yeah, it has a bigger molar mass.
You've been my student for almost a year now. One of the last questions I asked you, it's different,
It's different and then just says molar mass.
and
as
it
if that's-
changes.
As if that's like, yeah.
Gap Sean, thankfully you redeemed yourself, because then what did you say after I scouted you?
Bigger molar mass.
Yeah, because each atom of carbon has less mass than each atom of magnesium does. Okay, cool. So there's that. So the next challenge became, you had the elements, okay, hydrogen, magnesium. But then you get into, well, how do you find the molar mass of, say, can anybody name this carbons? 2 carbons, 6 hydrogens.
Single bond.
Single bonds. But what's the name of it?
It's an F, right?
2 carbons.
It's F because it goes meth F.
Meth, F,
Ethane.
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 Oh, it's the number of particles.
Ethane.
Number of.
I had to think through it. I was like single bonds. It's an A and 2 carbons. Ethane. We're good.
Yep, ethane.
We're good. We got there eventually.
So,
Carbon, 6 hydrogen.
the question being is that, how can you find the molar mass of this particular particle? Because it isn't like, again, it isn't like you can go, oh, here's ethane, I'll grab 1 molecule, I'll put it on the scale, and I'll get the number. Cool, all right? No. So what they did is they got very clever in terms of determining molar mass using gas law. And I'm not gonna expect you to go through the derivation, this is just the process. So if you take the ideal gas law and you change it and you solve for pressure, you get inert over volume, okay? Now this is where you have to merge some ideas together. N is the number of moles, okay? So if I take the mass and divide it by the molar mass, the grams would cancel out and you'd be left with moles. So for example, a simple example, if I take 24 grams of carbon and divide that by 12 grams per mole of carbon, how many moles am I gonna have? 2, okay? Because the grams would cancel out, the moles would flip up, and I would have moles. So, all I'm gonna do is a little bit of voodoo. So this is divided by volume. So I'm gonna rewrite that as grams over volume times RT, and then I'm gonna take the grams per mole, because I'm dividing it, and move that down there, okay? All I did was just rearrange this equation. Well, I know if I have grams per volume, which is mass per unit of volume, that's just a measure of what? Density, okay? So this is just density, and grams per mole is the molar mass, and all of that's going to equal your pressure, okay? So if you look at what macroscopic quantities you can measure, okay? So I'm gonna do a little bit of rearranging, go, oh, that's dirt over pressure equals the molar mass, okay? So physically, everything over here is relatively easy to measure, okay? Or at least it's measurable. Temperature, that simple, take a thermometer, boom, here you go, okay? Pressure, all right, even back then they had like very simple crude ways to measure pressure. You knew what the gas law constant is. Now, the density, that's density, which is mass per unit of volume. So if you knew the mass, this is where it sounds like a Dr. Seuss thing. If you knew the mass of the gas in the evacuated flask, then you can find the density. Well, if you know all of that, then you can find the molar mass of the gas. So for any gas, the macroscopic values that are easy to measure, mass, volume, temperature, and pressure, if you know those things, then you can find the molar mass of the particle. So this is a situation where he's like, okay, well, let's get a little bit clever. So this is a lab that we're gonna try and do on Wednesday. But I'm gonna tell you right now, if there's ever a lab, I'm gonna tell you straight up right now, if this lab we're gonna do on Wednesday. If there's ever a lab where you're probably gonna get huge experimental errors,
Please tell me you're not.
you guys are gonna shatter physics.
Oh, yeah.
Predictions.
This is gonna be good.
I won't even,
Huh?
I won't
Please
even
tell
be
me you're
here.
not grading up.
Oh, no,
So
I'm
wait,
waiting on your.
I'm gonna be in
Okay,
Dallas.
So it's just gonna be me and Charles? Oh no.
Oh my goodness.
It's just gonna be me and Charles.
Oh,
Cause I'll be in late from the AP Lit test.
You'll probably be
Okay.
done with the lit test by then.
I mean,
Well,
we
but
got
it's
back
Wednesday
on Wednesday.
schedule and
Oh,
we'll end
you're right.
at like,
yeah.
Makes sense.
yeah. So.
Yeah, so what you gotta do is take a little, like the bottom half of one of those plastic pipettes, and you put in like methyl alcohol or whatever you're trying to find. Then you put that in boiling water, and then you boil that off, and you assume that that's, in there's the methyl alcohol vapor. And then you have to weigh it, and if you're off by just a little bit, then everything just turns into a train wreck. And then you have to find the volume with a little pipette by filling that up with water, and there's just room for a lot of error,
Oh yeah.
okay?
Berg, we got a solid.
Yeah, I don't know how, but something froze.
Experimental errors on the
I don't know what you
easy
said.
lots.
It's
Lots.
Have you seen our experimental errors on the easy lots?
Oh, I know, but, well, it's actually one
I mean-
particular table,
like
so,
Berg, I got Avocado's
Yeah.
number as my
me and Charles. Or why do I have an experimental error of 300%? I don't know.
the worst I ever had was, I was doing a lab where you're trying to get Planck's constant 6.26 on 10 to the negative 34. I think we had like a 10,000% error.
Challenge
And-
accepted.
No, and the guy
Berg.
said, okay, that's not that bad. It's like, this is a 10,000% error, because it's really, really tough. to
No, it was good.
It's not bad, so, okay.
Not making me feel good about college, Berg.
I'm just telling you.
Calculate a number that small.
10,000. Really close. Just off by a hair.
Between the third best in the class with a 78 and then the off by 10,000% that's good, I'm not feeling confident about college right
Well, look at this, and then, yeah, that's valid.
But there's gonna be some helpful. You're not.
now.
You're not making it look easy to keep my GPA to be in the honors.
Our flippers would be.
Seems easy now.
Okay, so let's start off with something simple. And how you can use this equation. So I'm gonna give you carbon tetrachloride. So let's use this as a full basis of the review. Don't even worry about the gas law part of this. What will the structure of carbon tetrachloride look like, and what type of hybridization is carbon going to undergo?
S23.
Is that the new book?
Because there's
Yeah,
four
Yeah,
bonds.
Because it's got 4 bonds, 4 single bonds, 4 sigma bonds.
Yeah,
We haven't got our class sets in yet, or the ones in the library yet, but I'm just giving you back your copy,
okay,
because I already have one now. They sent me one too.
but that's the one for next year. Got it.
Yeah, that's the one we use next year.
And probably that'll be the last new chemistry book I might ever get.
Don't say that, we're not talking about your retirement.
Okay,
Just
You're
retire
gonna,
before you
listen,
finish
you're
work
gonna
before
spend
we
your
do.
whole life here, from cradle to grave, my friend.
great, that's
Part of-
awesome.
Maybe you're not, you're not there yet.
I'll, you know what, I'll do it,
Huh?
I'll do it if you do it. And you have full permission to haunt me if I leave before I make it to the grave, like if I'm like, oh, Stan's gone, he'll never know. You have full permission to haunt me. If I
He'll come back
do.
specifically just for that.
So does that mean like I have to like die in my classroom? Like define
Hold on.
define the
Hold.
end
Although
game.
that would be absolutely
mean-
outside in your classroom.
Define the end game.
I mean, Berg, I don't think we're very far if you keep jumping off chairs.
Oh, yeah.
Yeah.
Some kid's gonna kill you with that someday.
It has to be a
sledgehammer's the
moment
end.
when you have a student like Cohen. You're gonna get heated and be in one of your passions about Cohen's inability to shut up or do his homework.
Cohen, pull up the
And he has
Chromebook.
to be mid oh my God, Cohen, if you say one more word, the trauma.
No.
If that happens, I'm gonna tell every class from here on out, if I have a heart attack, the first person you go find isn't the nurse.
You go find this out and you say, Burkamp was yelling at this kid and now he's dead. And I just,
You were right.
it would
No.
be icing on the cake. Burkamp.
Okay.
It would make this-
Definitely
Yeah,
needs to be a
that's
Chromebook.
icing on your cake, not on mine.
Tell me it wouldn't make
No, it'll be the cake at your
Not
funeral.
only did you go out doing what
You'll
you
make the
love, but you
news.
also
But can you
traumatized.
That's what's important.
Can you imagine if you were Cohen, it was like, what happened? I caused Burkamp's death.
Exactly.
I killed my physics teacher. I get to go to WSU where I'm retaking physics and be like, oh, how'd physics go in high school? He died.
Did he quit? No, he died.
No, I rolled out my Chromebook and he
Go to your new
died.
physics. Yeah, I killed my last one.
We'll see how this goes.
Cursed him out so much.
You seem to forget he gets way more heated when he's grading tests. So
Oh,
there's gonna be one kid's
no,
test is just gonna
that's
be
it.
bleeding red ink, and he's just gonna be sprawled over it.
That's also valid.
Because the pen is open from where he's writing, there's just gonna be red ink on his shirt. It'll be poetic.
No, but you should do it during
He
class.
made his last test bleed.
No, it's gotta be like Berg. It's gotta be.
Hey, we give you our tests, right, and then you look at them.
Yeah, and then
What is
That's
this
what it's gonna be.
achieve? And then bam, dead.
But you
The
can't do
news
that
gets
for at
cold.
least.
Teacher dies.
6.5 days, Berg. You gotta make it 6.5 days
you
for me.
have to make it. You have to make it until I'm at least 40. So you've got to make it at least another 7.5.
Oh, really?
Minimum.
Why
Minimum.
40?
Because I just feel like that's a really good age. Do you want me to say 50? Because when I'm 50, you're going to be 80. And I didn't think you wanted to be
Around that long.
physics until you were 80.
So I'll be 7.5 years, I'll be 65-ish.
So yeah, you're about 32 years old.
Prime. You're in your prime. I don't know what
Wait,
it's
what are you right now?
I'm 58.
You're 58. I just
Yeah, he's
turned
getting fired because he
33.
sucks.
So we're
What?
25 years apart. So yeah, 40, 65.
No, not nearly.
The Medicare kicks in, so your future will be covered.
Hey,
Okay.
it's a diet class. They'll raise a lot of money for the Silicon Valley. There's someone.
Oh, that is true.
I came in with a chemistry delivery, and
We left
This
with
is all
Berg's death
recorded.
plan.
I derailed your whole class. And I just want to apologize for that. I was really just trying to bring you this book, but then you just got me on a tangent. So.
Berg,
I think you got yourself on the tangent.
Berg, if you're
Probably
like,
not wrong. Sometimes I am the train conductor and I don't realize it. You know what I mean? Like, it happens.
Berg, if you're killed in action, will the school play taps for you at graduation or something?
You're doing a great job.
That's
Yeah, what?
I said, if you're like killed in action, will the school play taps for you at graduation or something?
No.
We play
We're not
a
gonna
funeral
be
or
band.
church.
You have to like stretch
like,
strings
so
to
out of
various
tune.
lengths and then play each note by playing.
No, or have like you said, like the 21 guns, like 21, like.
Just leave
yeah.
Yes.
Some are way more interesting than others though. Some are just like pouring just like.
Yeah.
Or at least set off 21 hydrogen balloons.
Oh yeah.
It's a bright in the heart.
What about one last helium balloon? Send it into the sky.
Oh, so I will haunt you. I swear to God.
He will rise out of the casket.
Where
He will.
any of you show up to my funeral with a helium balloon, I will haunt
Some kid pulls out a Chromebook.
Birds. Actually,
He would
we're gonna
go.
put the helium to good use. We're gonna attach a huge helium weather balloon to you and just float you off into space.
Yes.
Like Katy Perry.
you. Instead of Viking people fire, I'm gonna have like a helium.
Morgan, you have it right. But instead of helium, we do hydrogen, and then we get a shoot of flaming arrow weapon
Yes.
that detonates in the sky. That's exactly how birds want to
Or
go.
Camp Rains on you.
If you ever feel a little ill, you have to come back. You can't go anywhere. If you catch a rib, you have to come back to school.
We're definitely gonna know.
Bird actually having a heart attack.
That was crazy.
Oh my God, I-
Okay, anyway,
He gave all of us the flu.
We're definitely gonna know if Charles
I'm
actually
never
watches
gonna
this or
forget.
not. Definitely gonna know if Charles actually watches this or not.
Every time he loses his voice, I get nervous. I thought my young self on my deathbed.
anyway, back
Stay
to our
with
story.
Bird.
I'll do what I can.
Stay with us.
So, back to the carbon. What type of hybridization is the carbon going to undergo? How do you know?
All of our bonds.
More regions of high electron density. If you were to compare the boiling point of carbon tetrachloride to carbon tetrafluoride, which one would have the higher boiling point? Which one would have the higher boiling point?
Fluoride.
Higher, right? Because it would be more.
No,
sticky.
chloride. Because it's no
Okay.
fluoride. I'm second guessing everything.
The fluorine is
No
more
idea
electron
what's
right?
going on.
So it's more sticky.
Started confident, just
The
fell off
core would be
quickly.
bigger, so it'd have more LDF. So it would be stickier.
Okay, what's the only type of bonding that either one of these could experience?
LDS.
London dispersion forces. Because everything is symmetrical, there's no dipole bonding. There's no hydrogen bonding, which only leaves you London dispersion forces. Was the only thing, and everything's gonna be similar except for the size of the electron cloud, right? So which one's going to be easier to induce a dipole moment on? The carbon tetrachloride or the carbon fluoride? Fluoride, why?
It's bigger.
It's bigger electron clouds, so it's easier to create a disturbance in it. So the carbon tetrafluoride should have a higher boiling point than because of the fact that it's stickier, okay? But which one would have a higher vapor pressure?
The tetrachloride.
Fluoride, because it's less sticky, so it'll bounce off each other more.
Yeah, so this is easier to separate into a gas. So this one would have the
Oh, I
higher
see.
vapor
Fluoride.
pressure, this one would have the higher boiling point, okay? They're inverses of each other. Okay. So, I want to find the density. You are my density. So, if you look at this and go, okay, I've got dirt, well,
You're in
density,
biology.
over pressure equals your
Do
over
not
mass.
never compare this to biology.
So,
Let's finish the exam. I don't want to talk about dirt again.
let's talk about,
I already talked about.
is there a question?
Yes, there was a question about dirt. There was a
There was
question
a
about
question
nitrogen in the dirt.
There's a question about.
Oh, yeah.
So,
You're not supposed to.
somebody take 35, take it a calculator, find the molar mass of the carbon tetrachloride. 35.5, 71.
You're doing it.
154. Okay, so we've got the molar mass. So if I solve for the density, I've got molar mass times pressure divided by RT. So the molar mass is 154. grams per mole. Now, I got 714 torr. How many torrs are there in one atmosphere?
No idea. I got a conversion thing saved on my phone.
760. When in doubt on a conversion, 760. So,
Yeah.
I'm just saying.
Am I supposed to know that?
So isn't it like 14?
Because 714 torr is the same as 760 millimeters, which is all equal to one atmosphere. So Jaden, take 714 and divide that by 760.
0.939.
0.939 ATM. We got 0.082066 liter atmosphere per mole Kelvin. And we've got 125 degrees Celsius. What are you gonna have to do with that? Grams. Add 273 to that, and we get 89398. And if you do all this, you get 4.43 grams per liter. Now, for those of you that are taking the test, this equation is not on your equation sheet unless they added it, okay? So there are certain ones, if you see the gas line.
Dirt.
Kinetics. No, they don't, but you decide they have to combine them to get to that point.
Just
So,
remember dirt ODP.
yeah, dirt over pressure equals dirt over mass.
Because it is.
Yeah. Yeah. It's a little bit.
So an interesting idea. How would that number have changed if we had used carbon tetrafluoride? How would, if everything is the same, except we use carbon tetrafluoride, what would have happened to the density? Increasing?
At the same time.
Everything's the same. The only difference is that we're using carbon tetrafluoride as opposed to carbon tetrafluoride.
Decrease.
Why?
Because like
Yeah, you've got a smaller number up here, so it would be less dense. Okay. Let me see, in the name of time. So I'm just gonna kind of briefly run through these equations.
Yeah.
Just some if you wanna work them, but it isn't really due.
Oh, I heard his
I need my teacher.
What?
We're gonna be spending a lot of time.
I don't figure out I can't save on my phone.
They were also talking
Oh my god, classes like that.
Yeah.
So I think it's classes.
I think you could lick it and survive. Let me see if I can, how long. Like safely, like I could live my life until my heart stops at 30.
At 30?
I have a lot of caffeine. And don't sleep near enough.
I got bad
Yeah.
genes.
Like, you're like 22, what are you doing?
This is a weird thing to look up on school.
Between my genes and my lifestyle, I'm probably
Oh, hold on. I want to see what AI tells me.
My genes were.
The odds are not in my favor.
No, they're not. In my
Can I
favor.
lick it? Yes,
Everybody on my
you
dad's
can.
side of
It's
the
the
family
first
has died in the past like 10 years from heart related.
Okay, so if you look on
Okay.
that green sheet again.
And I have genetic so like.
So let me kind of go over for those of you that are going to be taking the test and all of you in general. So on this equation sheet, so you've got the combined gas law, P1 V1 over Q1 equals P2 V2 over T2. And then you've got a couple of ones that are relating to this law of partial pressures. So this first one is the partial pressure of A is equal to the total pressure times, technically it's chi A. So chi A is the number of moles out of the total. So basically all this is saying is that if the total pressure in the system is 1.2 atmospheres, so let's say so the total pressure is 1.2 atm. And you know that there are 1 mole of hydrogen out of a total of 5 moles of total gas. So if you want to find out what the pressure is just caused by the hydrogen, it's just basically saying, hey, here's a percentage. So you take the total, you take the number of moles of hydrogen gas divided by the total number of moles in the system, multiply it together, that's how you're going to get that. So the bigger idea, and there's 2 ways that you can do this law of partial pressure. So one of them is N1 over N total. And this is where, I'm just showing you where the equation comes from. So that's N total is just going to be N1, N2, N3, just total number of moles in the system. So if you do a little bit of hocus pocus, and you go PV equals nRT, and you solve this for moles, and you get PV over RT, if you solve that for the number of moles. So if you substitute this, PV over RT, N for N1, and you're assuming that the volume and the RT are going to stay the same. So that would be like pressure 1 times volume over R2, pressure 1, and then you have the sums. Well, conveniently, the VRTs are going to cancel out. So you can also write chi, this law of partial pressures, in terms of either the number of moles or in terms of pressures. It's the same idea. So if you know that the pressure from the hydrogen is 1.2 atmospheres, and you know that there's 1.2 atmospheres of pressure from the hydrogen and 5 atmospheres of pressure from some other gas. So chi technically is usually like a decimal number. It's like 0.3, 0.2, something like that. If you don't like that, you can just think of it as like a percentage, saying, okay, hey, I got 1.2 points on the test out of a possible number of 10. What's my percentage? It's like a percentage calculation, you just don't put the percentage on the end of it. So this value of chi has 2 potential quantities. You can either represent it as a ratio of moles, or you can represent it as a ratio of pressures. Okay? Got that? Pretty simple. Let me see. Now, this is not due, but there's a couple of problems I want to work on this. We'll kind of go over so you see how they play out in terms of they put something like this on the test. This is not due, okay?
Not do,
Like
not,
Thursday, I'm rolling
Not do me no.
But Wednesday night, I have to run for a award.
Yeah.
So like Wednesday after the lit exam, I'm gonna come home and I'm gonna
You're like a
go
periodic table based on whether or not you can lick the element.
Oh, I've seen that.
I think.
I'm gonna probably shower and be like,
Oh, yeah?
or like put on makeup.
I don't know. I think you should get one for the classroom.
Bro, I wore makeup to the honors club thing.
Yeah.
I'm not joking. I sat down. I take off my makeup. I turned around to Sam and goes,
I'll give you one.
you think the rest
Yeah,
of us
you did.
I just like, you guys are pretty good. I don't even like when
He gets sat next to you for 1 semester, all of a sudden he doesn't do his work at all anymore.
to get back together.
Not most of them.
Somebody must have, somebody did it.
Somebody's talking a lot and
I
somebody's
didn't-
Like, I
like,
don't mean that in a bad
Hey, but you were the top of class before, right?
Probably, you're about
Somebody forgot to roll.
She did it. And then I turned back to the
Somebody got
mirror.
rejected.
My
from all
eyes
the
were
schools
like,
because they applied.
like around, like almost back. I was like, that's a lie.
See what you.
Yes, I can buy that poster for $12.
So you applied to send me,
Yeah?
Like, her face.
Hey, Walker, man.
And I literally just sat my friend. They know he has lots of my sat in it's like a psychology.
My mom,
That car was-
my mom's dad.
Most of the things on my to-do list for tonight are just, don't forget to bring this tomorrow. Bring my phone, bring my public charger, charge my calculator, bring that too.
Yes, have the calculator charge.
My calculator is currently giving me the, charge me.
Okay, so
Every time I turn it on, I don't know.
part of this is just terminology. So speaking of helium, so if you look at that question on 47, it says what mass of helium is required to fill a 1.5 balloon temperature at STP? So part of this is understanding what STP stands for. What does STP stand for?
Standard pressure.
Temperature and pressure. Now, on gas laws,
It's stupid.
what is standard temperature?
0 degrees Celsius.
0 degrees Celsius or 273 Kelvin. So 1 mole of a gas at standard temperature and pressure occupies how much volume?
22.4 liters.
22.4 liters. Okay? Now, if let's say on your test and you flip out, you go, oh my God, I don't remember. Well, volume would equal nRT over pressure, right? Well, if you, standard temperature and pressure, if you don't know what that volume is, you would have 1 mole. You've got your gas law constant, 0.08206. At 0 degrees Celsius, that would be 273 Kelvin. And your pressure is 1 atmosphere. You do the math, you get 22.4 liters. So you would just have to know, 47 isn't tough, it's just more stoic than anything. And you're just gonna go, okay, hey, I got 1 mass of helium. Well, here's your conversion. Oh, 1.5 liters of helium. Well, obviously I'm gonna have less than 1 mole because I got 22.4 liters of helium is 1 mole, and then 1 mole of helium is just 4 grams. So you can use stoic with that 22.4 liters just like you would do Avogadro's number, okay? But here's what's important. You can only use the 22.4 liters if you were explicitly told that you're at standard temperature and pressure. If you're not at standard temperature and pressure, you can't do that. Now, let's look at down here on this diagram on 63. So sometimes you see questions like this. So you've got this container with a valve, okay? And this is 2 liters of hydrogen, 475 torr, and then you've got
Unnecessary. You only have to convert the 470. Wait, did you convert to 4?
Yeah, they want the total pressure in core.
Oh.
Cringe.
But hold on, no, because your constant would be off, so you have to go to atmosphere and then convert to 4 at the end.
Oh, wait, oh, maybe that is true.
okay. So this is kind of a classic gas law question. So imagine that you have 2 different containers and they're connected by an opening and you have a valve between them. So you fill the left side with hydrogen gas at 475 torr, and then the left side is 1 liter of nitrogen gas at 0.2 atmospheres. And we're gonna open up the valve and I wanna figure out what's gonna be the total pressure in the system once I open up the valve, okay? So the easiest way to do this is just realize that combined gas law where you have P1, V1, over T1 equals P2, V2 over T2, but you gotta use this twice. So in this one, have they told you anything about the temperature?
No.
So don't even worry about the temperature part of it, okay? So this is why I'm saying that P1 over V1 equals P2 over V2. You can use this to probably solve 90% of gas law equations, okay? Now, so you need to make a choice. Do you want to work in atmospheres or do you want to work in torr? So in this question, it specifically says, and when you deal with gas law equations on the test, pay attention to what units they want it in. If they don't say what you want them in, probably you can just do atmospheres. But in this case, it says specifically in torr. So what's going to happen is that you've got pressure one, which is, we're going to deal with one side at a time. So you got 475 torr, and that has a volume of 2 liters. Then it's going to equal the new pressure, and then the total volume of 3 liters. Okay? So you're going to use P1 V1 equals P2 V2. Now, clearly, once I open up that valve, just think this through. Okay? And don't be afraid on the test. Just to step back and think through what the answer is going to be. Is it going to be big? Is it going to be small? Once I open up that valve, don't worry about the nitrogen part of it, just worry about the hydrogen part of it. When I open up the valve, what should the new pressure be? Bigger or smaller than 475? Smaller. Why?
Volume.
You increase the volume, you've increased the size of the classroom, you're gonna have fewer collisions with the timbers. So, in the name of time, if you do this, you get, 317 torr, okay? And then you're gonna do the same thing with the nitrogen gas. So, if you do that conversion, you get, somebody take 0.2 times, right quick, somebody take 0.2 times 760.
Rose, what'd you get for that one? Here?
0.2 times 760.
Oh, that was 152, wait, 152.
Yes.
So 152 torr, which is at 0.2 atmospheres, and that's 1 liter. And then that's gonna be X number of pressure times 3 liters, and if you do that math, you get 51. So if one is 317, the other one is 51, the total pressure would be
68.
68 torr. Okay? So in a problem like that, you just have to use P1 V1 equals P2 V2 twice. Those are the big ones off there. Okay, so I know May South people have to go. So,
Happy with it.
this isn't due, like I said, that doesn't mean you don't necessarily have to know how to do it, but I'll tell you right now, like that question, like 63, there's gonna be a question like that on the test, I promise you, okay? So make sure that you can do 63. I'll have a question like it on the review, just pay attention to that. For those of you that are taking the test, okay, I tried to get on the College Board website, you would ask about like the free response questions. It's completely locked up, like I can't, maybe it's just the teacher side that's locked
Maybe
up.
it's a user error. I heard you ask Mr. Fry about it.
Well, I did, it's like, and he goes, yeah, because I didn't know how to sign it.
I found your, like, the tests on.
If you go to the Blue Book app, you can take a practice test for each exam.
They don't have full length
They-
practice
on
tests,
a-
so
They
give
don't have
exams.
they don't have full length ones, but you can take a shortened practice one.
On
Where you
AP
can do
Classroom.
practice.
Yeah, on
and
AP
use
Classroom,
interviews.
There's a full MCQ and a full FRQ.
Yeah, that's what I thought.
So I've been working on MCQ.
Yeah, so I
That
sent,
one will
I sent you
actually-
guys out.
Yeah.
Yeah, there's
It'll-
isn't an
it'll
answer
actually
key
grade
for the
those too,
FRQ,
so.
and it won't grade
Do they not have them
It'll grade
online?
the MCQ.
It's there, but it just won't grade them, like you can see
Yeah.
what it is.
But like it
No,
doesn't give us
well,
a grading
you
guide
can take
either.
it,
But
on
once
the
you
Blue Book?
submit it, you can't go back and look at it.
So you don't know what the questions are anymore. The FRQs?
Really?
Yeah. You want me to show you what I see?
Well, I think I know where, yeah.
It grades the MCQs, but
So to tell you what,
for the ones that don't have any FRQs in them.
okay,
Yeah.
but you have to submit it,
Yes. You have to submit
and then
it.
they show you the answer.
Yep. It doesn't show you what the answers are for the FRQs.
Berkeley, I can't wait to tell you what I'm gonna tell you. I'm getting ready to take my comp sci final.
Oh, boy.
Over what?
Yeah, say.
What have we learned? Nothing.
Is anybody taking the,
Abby, there were some people that were gonna take it and then they dropped out of it like a week ago. Because they have, that thing you have a project final part of the test. Like where you have to submit your code by like April, like end of April. And they both, the two people that were gonna take it dropped out of it because
That's minus some class.
they didn't know enough.
That I don't.
So, oh my god, Avery's getting pregnant.
Oh my god. Yay!
oh my God, what?
My little sister, she has
She's getting
belly for one of our classes.
Avery's getting swabbed tomorrow, so much she said.
Because
That's what I thought you said,
And then we all cheered.
and I'm sitting
They're
there going,
ABCD,
how
LB2.
did this one?
What do you do?
but it's ABC.
We've been playing.
Our little sister, she's
I
what,
wouldn't
15?
play
She's
just
just, yeah,
She's 15.
What is it? Is it the
Should
term?
we
Yeah,
continue
it's an ABCTL
the
tournament. I don't know why they're
science
doing
tradition?
it.
I'm
I thought you were gonna say the teen pregnancy.
Unfortunately,
And I was
yes.
gonna
Do they have
say,
enough
whoa.
teams? Like that are in D1
You're gonna have a lot of
D1
fun
teams
because
have
you're
tennis?
probably gonna have her and Teague in the same class.
And their
Is that a bad
I don't know, that's
combination?
Yeah,
That'll be.
from what she said, yes.
Actually, no, it'll be 10, so.
There's a lot of pressure.
That might be the
I
definition.
am.
Yeah.
English.
You seem to be enthralled with the syringe.
Yeah.
Have you never noticed Will Stanley plays with that every day in physics?
Yeah, but I just think,
Heading in, period, turning off my phone. They started playing Despacito. Somebody in the hallway
Yeah,
was playing
really.